Ladies and gentlemen, our next lesson is factoring trinomials where a leading coefficient is greater than 1. What do I mean by a leading coefficient? Well, if you look at our example here, ax plus bx plus c, the a, b, and c are coefficients. A is the leading coefficient. So what we've been used to in the past is, say for instance, y squared plus 12x plus 27. When we factored out our binomials from these trinomials, we've been accustomed to this being a 1. So it's been easy mostly. So when we go to factor this out, all we had to do is say, okay, what two numbers multiplied by each other would give you 27, but would add up to give you 12. So we would say y and y, and then we would have 9 and 3. And that would be our answer. But what if this coefficient is greater than 1? Now you've got to do something different. And that's what I'm going to show you in this lesson. So let's get started. Our first problem is 6x plus 17x plus 5. As you can see, the leading coefficient or a coefficient is 6. It's not by itself. So it's 6x squared plus 17x plus 5. So what do we do in this type of situation when we're factoring trinomials? So what you want to do is look at the first and last coefficients, which are 6 and 5. Find out what the product is or multiply those. 6 times 5 is 30. And then for the middle coefficient, find out what two numbers that you multiply to get 30, but when you add them, you get 17. So we could go off to the side and figure out, okay, we had 6 and 5. 6 plus 5 does not equal 17. 30 and 1 gives you 30, but 30 plus 1 does not give you 17. What about 15 and 2? There we go. 15 times 2 gives you 30, but 15 plus 2 gives you 17. So what we're going to do is rewrite this problem, 6x squared, where we break it up and use these coefficients to match exactly how the problem is. So we have 6x squared, but we want to represent the 17x differently. So we're going to say it's 6x squared plus 2x plus 15x plus 5. Now this is the same problem. I've just broken up the 17 into 2x and 15x, the 17x. Same problem. So now what we're going to do is be able to factor out coefficients and variables to make sure that we see what these new binomials are. So now we're just going to look at this portion of the problem and this portion of the problem. So what can I pull out of this 6x squared plus 2x? What I mean is, what can I factor out? Well, both of these variables can be factored out by 2s. There's a 2 and a 6. And then they both have an x in them as well. One of them has an x squared, so you can't factor out an x squared because this one only has an x. So I can factor out a 2x from both sides. So what does that leave me? There's still an x left, and then there's 3. So there's 3x, and then I factored out a 2x, so there would just be a 1 here. So there's 3x plus 1. You see how that works? If I were to multiply this out, 2x times 3x gives you 6x squared, and then 2x times 1 gives you 2x. But I've pulled out the 2x. I've factored out the 2x. Now let's look at this other side of the problem. What can I pull out or factor out from 15x plus 5? Well, I could also pull out a 5 from both, because you could take a 5 out of 15 and you could take a 5 out of 5. I can't pull out an x because only one has x, so I can only pull out just the 5. So I'm going to pull out 5, and what do I have left when I pull it out? You have 3x plus 1. 5 times 3x gives you the 15x, and then 5 times 1 gives you the 5. Well, now look at here. We see commonalities. We have a 3x plus 1 pulled out here and a 3x plus 1 pulled out here. So by the distributive property, we can go ahead and say that the factor for this trinomial is 3x plus 1. And then what do we have left? We have a 2x plus 5. And this is how you factor a trinomial that has a leading coefficient other than 1. Does that make sense? Okay, we'll move on to the next one, and hopefully you can get it as we go along. So let's go to the next problem. Our next problem is 7x squared plus 29x plus 4. So just like the last problem, when we're looking at factoring out a trinomial that has a coefficient, a leading coefficient other than 1, which is what we've worked on in previous sessions, we now have to do something different. So we're going to take the first and last coefficient, which is 7 and 4, multiply those, we get 28, right? So with the 28, we need to find two numbers that when you multiply them, you get 28, but when you add them, you get 29. And that's going to be a pretty easy one. We could say 28 times 1. 28 times 1 gives you 28, but when you add 28 plus 1, that gives you 29. So now we're going to restate this problem again. We're just going to write it a different way. We're going to represent the 29x as 1x plus 28x. 28x plus 1x is 29x. And then we have our plus 4. Now we're going to find commonalities, see what we can pull out of each part of the equation in order for it to be factored. So let's look at just this part of the equation, and then we'll look at this part of the equation. So if we look at 7x squared plus 1x, your next question is, what can you pull out or what can you factor out? Well, both sides have at least 1x. You can't pull out 2x's because only one has an x squared. So we'll pull out 1x, and that leaves us, we can't pull out anything with the coefficient, so that'll leave us with 7x plus 1. Because x times 7x gives you 7x squared, and then x times 1 gives you 1x. So over here, let's look at what we can pull out. It looks like we can pull out a 4 from each side. We can pull out a 4 from the 28 and a 4 from the 4 and see what we have left. So if we pull out a 4 from 28x, that'll leave us with 7x. And then we pull out a 4 from the 4, that'll leave us with 1. And here we go again. We see the commonality of 7x plus 1, which is one factor. And what do we have left? X plus 4. All right, is this starting to make sense? Hopefully this is starting to make sense. These are factors. This is when you factor out a trinomial. So now let's look at the next problem. Okay, our next problem is 10x squared minus 43x plus 28. Okay, just as previously, we're looking at trinomial that has a leading coefficient other than 1. What we're going to do is take the first and last coefficients, 10 and 28, multiply those, we get 280. Now the next thing we need to do is, we have two numbers. What two numbers that when we multiply those will give us 280, but when you add them, you will get a negative 43. Now that can be a little bit difficult, so we could try some things out here. So I'm seeing that the 10 and the 28 are both even numbers, so I'm going to take a guess here and see if I'm right. So let's see if we could do, let's see, 35 and 8. Let's see how that works. 5 times 8 is 40. Carry the 4. 8 times 3 is 24, plus 4 is 28. So we have two numbers that when we multiply them, we get 280. But if I put a negative on these, if I were to add those up, that would give us a 43. So when you have two negative numbers and you add those, it's just like adding them without the negative number. So 35 plus 8 gives me 43, but it's still negative. So in that case, we're going to represent our negative 43x as negative 8x minus 35x, which gives us our negative 43x plus 28. Now, I was able to guess these numbers on the fly, but what you'd have to do is go down the line and say, okay, we've got 10 and 28. We've got 2 and 140. You'd have to go down the line to figure out what two numbers, when you add them, would give you the negative 43, but when you multiply them, would give you the positive 280. So we have 10x squared. We're representing the negative 43x as minus 8x minus 35x, and then we have plus 28. So now what we're going to do is factor some things out. So we're just going to look at this part of the equation, and then we'll look at this part of the equation. So we have a 10 and an 8. Looks like we could factor out at least a 2, and then each variable has an x. So we'll factor out a 2x. That leaves us with 5x minus 4, right? So then we usually have a plus here. So what can we pull out? Each one of these has a 7 that you could pull out. You could pull out a 7 from 28. You could pull out a 7 from 35, but 1 is negative. So we'll just have this be a negative 1. And then we'll also pull out a 7. When we pull out a 7, a negative 7 basically, that leaves us with 5x minus 4, because a negative 7 times a negative 4 would give you a positive 28. So I see what we have in common here is your 5x minus 4, which is a factor. And what do we have left? You basically have a 2x minus 7, because negative 1 times 7 is negative 7. All right. Hope this helps. We'll move on to the next problem. All right, our last problem for this section is 3x squared plus 24x plus 45. Now, this is a little bit of a tricky one because we see here there's a 3 leading coefficient that's other than 1. But what else do we notice in this problem? We could go ahead and factor out a 3 in the beginning, and that leaves us with x squared plus 8x. And then if you could come off to the side, 3 goes into 45 one time. 4 minus 3 is 1. Drop the 5. 3 would go on to 15 5 times. So now you have x squared plus 8x plus 15. Now you see how that's different from the problems we were doing before, but it looked as though we needed to do the same thing as we were doing before. But sometimes these can be a little tricky when all you have to do is just factor out a common number. And now this factor goes back to what we originally did with the trinomials where the leading coefficient was a 1. So we have this 3 outside here. Now this becomes a regular x squared plus 8x plus 15. We find what two numbers multiplied by each other give you 15, but when you add them, you get 8. That's a 5 and a 3. So we have x plus 5 and x plus 3. So you've got to watch out for these. So make sure that you don't have to factor out in the beginning. Then it just becomes a regular trinomial with the coefficient of 1. So I hope this helps. If this helped you, send it to somebody else. Please like and subscribe, and we'll see you in the next video.